Hi, everyone. Welcome to Business Intelligence in Minutes with Amazon Athena and QuickSight. So what we're going to look at today is how within minutes we can build a data processing pipeline to help explore and analyze data rapidly. Before we get started, just a quick show of hands. How many people in this room have spent significant amounts of time processing, exploring data only to find that it's low-grade data or it doesn't provide them the insights that they want? I see quite a few hands go up, and I've certainly struggled with that in other roles. So why is this exploration and processing and analysis of data important? In a traditional system or a traditional organization, we have our legacy data sets, which are then augmented by a newer data feeds, say, for example, from IoT devices or real-time applications. It's becoming increasingly hard to understand which of these data sets or combination of these data sets are going to provide us those data mines of information, and which of these are going to lead us down dead ends. So we're going to run a quick experiment today. We're going to take a large data set, which is a data set consisting of weather reports across the globe over a 10-year period. And we're going to look to explore that and analyze that and see if we can drive some useful insights from it. Why has this traditionally been a problem? Now, if we take the time from when you're able to capture data to the time when you're able to start consuming it, let's call this time to value. Now, this time to value can be extremely long, and we're talking months, if not years in some cases. So if you've got a large reporting data set or a large reporting system, it can take months to set it up to deliver those reports and those insights to the business. What that means is, given that the extreme amount of time it takes to set up that system for this reporting, the cost of failure is high. So we need to be sure up front that the data we're analyzing and the reporting that we're going to run off that is going to provide the right insights to the organization before we get started. What if we could reduce this time to value? What if we could start to process, explore data quickly, and that can really unlock experimentation and help us move rapidly? So what that means is we can look at permutations of our data sets that we have. We start to explore them. We start to analyze them rapidly. We will find data sets that are low grade, which don't have the required information that we need, and we can simply chuck them away. The fact that we haven't spent a lot of time and invested a lot of cost up front in doing that analysis, it's not really a problem. But what we will eventually start finding are those data sets that are useful, that have the right insights for us, and then we can look and see how we can enhance those data sets and that information and build them into our production data analytics systems. Now, if we look at the tools and the evolution of those tools in the analytics space, so to start off with, we have our standard SQL databases. These have been the mainstay of most of our organizations for a very long time. They're built to work with structured data, so you decide the schema of your data up front, and you start to store it into a database. They work fantastically well if you're going to be using standard SQL to start to query that database, but they're traditionally not built to handle or scale beyond a handful of nodes. So what that eventually ends up meaning is that you're going to eventually get to a point where you can no longer store additional data sets within your database. Or more importantly, the analytics that runs off the back of these databases starts to impact production workloads and transactional workloads that run against these data sets. To solve some of these problems, we came up with the concept of data warehouses. An example of this is Amazon Redshift, which is a low-cost petabyte-scale data warehouse. Data warehouses are inherently designed to scale compute across multiple nodes, so you take care of some of those scalability problems. They use optimized storage and query execution to enhance performance, but you're still dealing with structured data. So the schema of your database or the data warehouse needs to be determined up front before you start to ingest data into it and start to query against it. But what if our data set was changing? What if we need to start ingesting a secondary data feed or a data set, the schema of which doesn't match our existing data warehouse? Now, we have a couple of options now. So we can either look to build a new data warehouse or a new database within the data warehouse, or the tedious task of updating schema on the fly, which gets very complicated and complex very soon. To solve some of these problems, along came Hadoop Frameworks. So these frameworks help you to solve the problem of that determining the schema up front. So what you can do, and the flexibility these provide you, is the ability to ingest any amount of data in any format, as long as you have a safe and secure place to store it. But then you only need to worry about the structure and the schema of that data when you look to consume it. These are inherently designed to scale across multiple compute nodes, so you solve some of those scalability problems as well. However, you usually end up leveraging someone like data scientists to help you, or data scientists or operation teams that are really skilled in these frameworks to help you get started and get meaningful insights from your data. So there can be somewhat of an upfront skills gap that you need to fill before you can start using these frameworks. What we're going to look at today is a set of AWS services that leverages the flexibility and scalability of these frameworks, but makes it easy for you to get started with and consume those data sets and start to analyze them. So the services we're going to be talking about are all managed services and serverless. So what that means, at no point today will you see me spin up virtual machines or instances. They're built to be scalable. So if the amount of data that you need to ingest and process, it increases, resources are spun up by these platforms and these services to be able to handle that data. And also, just as importantly, as you start to stop using those services, as your consumption goes down, these services can then be scaled down. And so what that means is you're never paying for idle compute. So the dashboard that we're going to build today, if we don't end up touching that dashboard for, say, a couple of weeks, we're not going to be paying for the compute that underlies that platform. And since we're going to be using the AWS global infrastructure, high availability and fault tolerance comes in built in by default. So what that means is we no longer have to worry about storing multiple copies of our data to make sure that it's durable and secure. And also, we no longer need to run high availability, complex clusters to prevent and guard against individual node failures. All of this is handled by the platform. So let's have a look at the serverless business intelligence pipeline and stack that we'll be using today. To start off with, we'll have a data storage layer. This is where we're going to be ingesting our data and possibly the outputs of these analyses. We need it to be flexible enough to dynamically scale and store any amount of data from anywhere. We're going to then make use of metadata cataloging services. So as I mentioned, but since we're going to be using big data platforms, it means that once we start to consume that data, we need to infer and understand the structure of that data. And that's where this metadata cataloging service helps us understand the structure of that data and store it into a searchable metadata store. Once we've ingested our data, we've started to understand the structure of that data, we can get down to exploring that data. And that's where the analytics engine comes in, which can be used to use standard SQL to start looking at exploring that data, understand whether it's relevant to us. So for example, if you take the example of the weather data, does it actually have data points which are relevant to Australia? Do we want to go further with this analysis and this exploration? Now, if you are comfortable using SQL to explore data, analyze it, that's maybe the point, the analytics engine may be the point where you start to consume that data. But for the rest of us, we can build a visualization layer on top. So we want to be able to build dashboard and reports off the back of it, dashboard reports which are interactive and which can be shared with other users. So a quick overview of the services that we're going to be leveraging for this. So at the data storage layer, we're going to leverage Amazon S3. S3 is a highly scalable, highly durable data storage platform, which is designed to store any amount of data from anywhere. One of the key tenets of S3 is the ingestion flexibility. So to upload your data to S3, you can, of course, use the web console that we provide, but you can use the CLI, you can use an API, you can build a custom application using the SDKs that are available to you. Or if you're using software from the vast ecosystem that already surrounds S3, you may already have integration points into this data storage platform. Now, the distributed nature of how S3 is designed allows us to process large amounts of data efficiently. So that's the processing flexibility that comes within S3. And of course, if you're moving your data to the cloud, you want to make sure it's secure. So S3 provides fine-grained access control and auditability. And at the same time, it gives you different options to encrypt your data at rest and allows you to meet some of the most stringent regulatory requirements when it comes to security. Now we move to the next layer, which is the data processing layer. So we mentioned the concept of a cataloging service, and we leverage AWS Glue for that. Glue, as the name suggests, is a service built to glue together multiple data processing services on AWS. It provides you a Hive-compatible metadata catalog that we'll be leveraging. What's really cool about Glue is the concept of crawlers. So what you can do is you can spin up a crawler, give it access to the S3 bucket where your data is stored. The crawler goes in and starts to look at and infer the schema of that data and stores it into that searchable catalog. The other functionality that Glue provides you is ETL. So say, for example, you've got a data set that's in CSV format. I need to transform it into Parquet for optimal and optimized querying. You can easily do that with Glue. In fact, the data set that we're going to be looking at today, I was able to pull it from a bucket up in the North Virginia region, pull it down to Sydney, transform it from CSV to Parquet, repartition that data, and store it into a bucket in Sydney within a few minutes. And that's the flexibility and scalability that Glue provides you from an ETL perspective. Now, as we come down to the querying language and how we're going to be start looking at and analyzing and exploring that data, we leverage Amazon Athena. Amazon Athena is an interactive query service which lets you easily explore and query against data in S3, directly from S3, using standard SQL. Keeping with the theme of serverless and managed services, with Amazon Athena, you only pay per query. So what that means is if I'm not running any queries against my data, I'm not paying for anything. But as soon as we decide that we want to start exploring that data and run queries against it, then we pay per query and the amount of data that's analyzed or the amount of data that's traversed. It's standards-based, so it's built on the Presto framework. And while we provide you a console to actually script and run those queries, you can leverage your regular SQL tools using ODBC and JDBC connectors. And it's fast and serverless. So what that means is Athena is always ready to go. So as soon as you write your query in and you hit run, it will handle the rest. So it will spin up the required resources to actually go in and start analyzing that data. To visualize that data and to start to explore it a little further, we're going to leverage Amazon QuickSight. So Amazon QuickSight is a business intelligence tool which is meant to bring BI to the masses. So it's extremely easy to get started with, and you don't need to have experience using BI tools in the past to be able to start using it. It provides some great feature sets in terms of, the example is autograph. So based on the data set that you choose to visualize, it will recommend an optimal visualization for it. And then we can use QuickSight to build those interactive dashboards and those reports, and we can share it with other users within the organization or outside. So this is a recap of the architecture quickly. So we're going to use Amazon S3 as our data storage layer. As I mentioned, in the essence of time, I've already pre-populated that data in S3. So it's a data set of reports from weather stations across the globe over a 10-year period. We're going to use AWS Glue. We're going to spin up a crawler to go in and start to explore that data, look at the schema and the structure of that data, and provide it back to us. And then once we know the structure of that data, we're going to use Athena as an interactive query language and run SQL statements to look at that data further. And then, obviously, we can use Amazon QuickSight to visualize that data, explore it a little further, play around with it, and hopefully get some useful insights from it. So we're just going to dive in. Could you switch over to the laptop, please? So as I mentioned, the data set is already partitioned by year, and is stored in S3. So this is where the data set lives. We'll just hop over to the Glue console to start to play around with this now. So the first thing we're going to do is we're going to create a crawler to go in and start to infer the schema of that data. So we add crawler, we give the crawler a name. We choose the data store that we're going to be using for this. So S3 is what we'll be using. And we specify the bucket where this data is stored. We'll just be using a single data store for today. And then we choose the permissions that we're going to grant the crawler to actually go in and be able to read data from our S3 bucket. So we can create an IAM role to do that. I have a pre-populated IAM role that has the right permissions to this bucket to be able to go and read data from. We have the option of running the crawler on demand or schedule it. So, for example, if you've got a bucket with the changing data set, you could have this crawler run every hour, every day, every week, whichever makes more sense. So we're just going to run it on demand today. The data catalog that comes with Glue has the concept of databases and tables where this metadata information is stored. So we'll just create a database here. We'll just call it, we'll just give it a name, create, and then a table will be created within it. So next, we just validate all the configuration options we chose, and we hit finish. Now, our crawler is ready to go, and we can now start running it. Now, this takes about 35 to 40 seconds. In the essence of time, I'm just going to skip over this stage, and I've already done this exercise before, so if you can look at it, this is what we did. It took about 35 seconds to go into the same S3 bucket with the same row and crawl that data. We hop over to the databases that I created. So we look at the database here. We look at the tables within that database. And this is the table, the metadata catalog table that we have here. So it provides us information around what was the S3 bucket that we were looking at, what's the format of that data, which is Parquet. And it also gives us information about the number of records in that data set. So in this case, it's around 37 million records that we crawled. And down here, we have the schema of that data. So as we can start to now understand what that data is made up of. So we've got country code, which we can leverage later on to understand which country codes we want to look at. We've got information like latitude and longitude, so we can possibly look at visualizing that data in a geospatial map. And we've got weather information like dew point, wind speed, precipitation, fog, snow, all of that. And then we've got number of years of data, which is where the data is partitioned with. So what we've done is we've taken that data set, we've crawled that data, now we have an understanding of how that data is structured. Where do we go from here? So let's hop over to Athena to be able to run queries against that data. I'll just hit quick refresh. It seems that the new database that we created, the crawler is completed, so we have that database. So let's have a look at that. It shows us the table within it, and the same schema that we saw from the Glue metadata catalog. So it's just pulling information from there into Athena. So we can now use standard SQL to explore that data. So let's do a quick count on the number of rows of data within that data set. So as I hit submit, Athena goes in, starts to explore that data. Keep in mind that that data is still stored within S3. At no point here have we moved into a database. So within a few seconds, it's able to tell me the data has 37 million records. Not really useful information, but we just validated what the crawler told us. We can then run a few more complex queries. So what we're going to do now is we want to understand whether this data is relevant to our use case. We want to explore weather data for Australia. We want to see if it actually contains data for Australia. So we're just going to run a quick query to sort the data and give us a number of records by year with country code AS, which happens to be the format that they're using for Australia, or the country code for Australia that they're using here. So we go ahead and run this query, and we expect that within a few seconds, it'll be able to report back. There you go. So around 3.4 seconds, it's able to tell us that we've got 10 years of data in there, which is relevant to Australia, and a pretty consistent number of data points against each year. So we now understand, we had a look at our data a little bit, ran some SQL against it. We understand that this data set seems relevant to the use case we're looking to fulfill, which is to explore weather data for Australia. So it has data sets over the 10-year period for Australia. We'll hop over to QuickSight now. So now we're going to start to visualize that data and gain some insights from it. So let's create a new analysis. We're going to create a new data set. We're going to choose to source that data via Athena. We're going to give it the data source a name. We're going to create this data source. What this will do is, via Athena, it'll plug back into that Glue metadata catalog and start to give us back, this is the databases I have that you could look at. So we're going to look at the database we created and the one table within it. Now, QuickSight gives you the option of loading your data up into memory in what we call a spice engine. So if you know the data set that you're going to be using is consistent and it's useful, you could choose to load it up into a memory engine to allow for faster querying. But since we're still exploring this data, we're still trying to understand it and make sense of it, we're just going to query it directly from S3. So we're going to choose to directly query our data. And that's it. We hit visualize. Cool. So now we're into the QuickSight Console. So similar to what we saw before, these are all the data fields within our data set. And QuickSight infers which of these are metrics, which of these are dimensions we can look at this data. So let's just hit country code and let QuickSight visualize this for us. Again, what QuickSight is doing here, leveraging Athena and the SQL engine that it provides, is going in and running SQL queries against our data set directly in S3. So yeah, just an example, there's a large number of data points against the US, which is reasonable and expected. And what we've done here is we've chosen the option to autograph. So so QuickSight suggested that we use a horizontal bar chart to explore this data right now. And that's what we've done. Let's instead hop over and look at years and remove the country code. Actually, I'll have to redo this, sorry. I'm just going to choose year here and just show me how many years of data there is. And, while this makes sense, I may override it, saying that I want to look at it in a line chart format. There we go. So it's data from 2006 to 2015, so around a 10-year period. And as we see, the amount of data points are increasing. Good to know, but not really insightful. Right? Now let's see if we can now start to visualize some of this data. So let's choose country code as an option. We had latitude and longitude as dimensions here. Let's choose a geospatial map and choose the latitude and longitude within it to start to visualize that data. And for the sake of clarity, let's use country code, drag it across, and say that I want my data to be color-coded based on the country code. Now what this has done is drawn us a map, colored by country code of all the data points within this data set across the globe. So we've just visualized approximately 30 million rows of data within this data set. Now, we want to filter this down to Australia. So we want to get rid of all the information that surrounds it. So what we'll do is we'll go ahead and we'll create a new filter. We're going to say we're going to filter by country code. This is going to provide us a filtered list. So this, again, is going to go in, explore the data, and figure out what are the possible values that country code can take. So it allows that drop-down functionality for us to select. There we go. So we're going to just choose AS. We're going to hit apply. So we've just narrowed our selection down to the data set for Australia. Now, right now, all we have is the count of records for Australia over a 10-year period. Let's start to see if we can remove the dependency in country code, so we're only exploring one country code. But let's start looking at precipitation, for example. With precipitation, we don't want the sum of whatever metric it is, we want the average. So we want to choose average here and visualize that data. So this shows us the average precipitation across all the weather stations that have submitted their reports across Australia over a 10-year period. Can we get some insights from it? Well, I'm looking to go on holiday in December. I was wondering which part of Australia can I go where there's the minimal chance of rain. Let's have a look. So we add a new filter now. So month was one of the dimensions we had. So I choose month. Again, let it populate the list. So it's using numerical format for month, so 12 would be December. Let's see what that looks like. So the data set may not be insightful enough to tell me exactly where I need to go, but one thing I do know is I want to avoid the northern coast of Australia for my holiday. So just to give you an example of what you can do with some of this data, again, we may be able to find further insights if you start to visualize it further, but just a quick example of what's possible. Can we switch back to the presentation, please? So I hope what this has done for you, actually, we need to go back a little. Sorry about that. So again, just recap what we did. So we have our data set in S3. We use Glue to explore that data, infer the schema, use Athena to query against it, and then use QuickSight to visualize that data. And throughout this process, the data set remains in the format that was in, Parquet, within S3. So we're not changing that at all. So what I hope this has inspired you to do is go back, look at some of the data sets within your organization, start to quickly and rapidly explore them, experiment with them, and see whether they're able to provide any insights to you. So this link is actually to a blog post, which actually talks about and goes through this process with a different data set, but the concepts remain the same. And it goes in detail about how you can run ETL, transform that data, and start to explore it with the tools that we looked at today. Before you leave, can I please ask that you use the QR codes on your cards to submit feedback? And if you want, on the way out, could you please scan your badge, and we'll shoot across these resources along with additional resources to get you started in this front. Thank you.